All right, so let's start with section 3.3, our scientific notation. There's a couple of other videos on here that your classmates have made. I would highly recommend that you take a look at those and see their explanations as well. Scientific notation, what is it? Well, it is the easiest way to write very, very large or very small numbers. And how do we do that? Well, first we're going to need to write a decimal number. This decimal number needs to be between 1 and 9. And, well, okay, that's just the rule. And then we're going to use 10 raised by a power to move the decimal. What does that mean, Mrs. Graham? Well, let me show you what I'm talking about. If I have a number like 9,200,000, I can write all of those zeros, or I can recognize right here that all of my non-zero numbers are 9 and 2. And so I've underlined that with green. So instead of writing 9 and 2, I take my non-zero numbers and I write them as a decimal number between 1 and 9. So since it says 9 and 2, I would write 9.2. Now, if I had a decimal between 9 and 2 and I wanted to move it to the end of this number, I would move it 1, 2, 3, 4, 5, 6 spaces to the right. Now remember when we were talking about our special case for tens, if I want to move that decimal place 6 spaces to the right, it's 10 raised to the positive 6 power. So 9,200,000 can be written in scientific notation as 9.2 times 10 to the 6th. Now that's a very large number. What about a very small number? A very small number, I have here 0.000000539. I find my non-zero numbers. I've underlined them in green. Here's 5, 3, and 9. I'm going to write my non-zero numbers as a decimal. So instead of writing 539, I write 5.39. So I put my decimal right there. Now, if my decimal was right there, where would I have to move it to get to where the number actually is? I'd have to go 1, 2, 3, 4, 5, 6, 7. I'd have to move 7 spaces to the left. And remember our pattern from our 10 exponents? If I want to move that decimal 7 spaces left, my exponent needs to be -7. So the scientific notation form of 0.000000539 would be 5.39 times 10 raised to the -7th power. Now, I am going to go on, but you can pause the video here, and I want you to go ahead and try these. Can you write 48,920,000 as a scientific notation number? Remember, you need to find all of the non-zeros and write them as a number that is a decimal between 1 and 9. And then I have another one for you, 0.0007934. We want to write that in scientific notation. Again, remember you need to look for the non-zero numbers to make them into the decimal. And keep track of, is this number going to be a positive or a negative? Okay. So hopefully you were able to do those ones. Now we're going to be looking at a couple of other examples. We're just going to go the other way. So if I am given a number in scientific notation, like 1.398 times 10 to the 5th, I notice that my non-zero numbers are what's written here, and that's 1, 3, 9, and 8. And I have an exponent of 5. So if I take my decimal from where it is, and I want to move it 5 spaces right, I'm going to go to the right, 1, 2, 3, 4, 5, which I've written here. 1, 2, 3, 4, 5 spaces to the right. That's the place that the decimal actually is. So this number in standard form, this is standard form, would be 139,800. If I have a very small number, 9.2 times 10 to the -8, I'm going to write my 9 and my 2. Those are my non-zero numbers. See? My non-zero numbers. And then where I have that decimal, well, because it's a -8, I'm going to move it 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. And that's where the decimal goes. So to end this, though, when are these going to be used? What information can it give us? Well, two main things right now. One, you can compare numbers. You can look at a number like 1 times 10 to the 5th versus 1 times 10 to the 2nd. And remembering our properties of tens and how we deal with exponents, we can say that 1 times 10 to the 5th is 10 to the 3rd times larger than 1 times 10 to the 2nd, because 10 to the 5th divided by 10 to the 3rd is 10 to the 2nd. Remember, when you divide exponents, 5 minus 3 equals 2. You can also sort of determine which unit is going to be best to use, especially when you're doing something like, oh, I don't know, the science fair. You can look at the number and see which is the best unit to use. If you had a unit that was 14,300,000 grams, you could write that as a 1.43 times 10 to the 7th grams, but it would probably be best written with a larger unit if it's possible, which in this case you would write 1.43 times 10 to the 4th kilograms. So this is a smaller issue. This one is, if you can recognize the patterns, you're able to look at them individually. But ultimately, scientific notation lets you write very large and very small numbers in a very small amount of space.